I want to see next class. Huh? It is non-linear, but I want to see the derivation. Many guys could be having many kind of ways to derive it. I want to see it. Okay, last question. d2u by dx square. What is this operator? Linear, non-linear? Linear, non-linear? Remember the previous one. This is homogeneous or non-homogeneous? It depends on the function of x. It is non-homogeneous. This function of u homogeneous. It is constant, again non-homogeneous. So depending on that, if you assume it is constant, it is non-linear homogeneous system. Now you come back here. Assume it is constant. What is this? Of course homogeneous. It is now question whether it is linear homogeneous or non-linear homogeneous. Is it linear operator or non-linear operator? That's what I'm asking. LU plus B. d2 dx square u plus b plus next term is what? Please, I am getting bored here. What is next term? What is that? Yes, madam. d by dx. Am I correct? Okay, what you are getting? d2u dx square, d2b dx square plus what you get here? du dx plus dv dx, right? So it is du dx plus dv dx whole square. So you will get what? du dx whole square plus dv dx whole square plus 2 du dx dv dx. What are you getting here? This is LU, this, and this will give LU, this will give LB. Am I correct? This is the extra. Linear or non-linear operator? Non-linear. See, so nicely you can actually differentiate linear operator, non-linear operator. Can you get back and come here and can do that? How to prove it? Okay, now tell me the steps. Now we have got it. Now that's why I wanted to do this program earlier. In the left hand side, who will do quickly with me? ddx square u plus b. Next, plus what? U into. That's wrong. That's wrong. That's what I'm saying. That's your concept wise not correct. If you say it is LB, then automatically this all will be V. So for this kind of cases, you cannot write L separately like the first non-algebraic system. You should always write like this. So when it is having LU plus B, wherever U is appearing, understood? Like a non-linear operator algebraic system, I could not write x equals to b. I have to write f per u vector equal to 0 because of this kind of thing. Okay, so it is now u plus, that's why I say slight mistake was there when we are talking about u plus b ddx of u plus b plus u plus b. Right? Now it is very straightforward. d2 dx square u plus here it is coming u ddx of u plus u. Then you have d2b dx square plus you have b dv dx term plus b. Now extra terms are coming. What is that? U dv dx plus b du dx. U dv dx plus b du dx, and which is extra. So that means operator is non-linear. Am I correct? So it is nothing but LU, nothing but LV, some extra term. The operator is non-linear. Yes or no? Agreeing or not? If you don't take me, please catch me. I can pause here. If you don't take me, please catch me. If you don't, please catch me. If you don't, please catch me. I'm here pausing. If you don't take me, please catch me. See, basically, when we have x1 square plus x2 equals to 2 and x1 plus x2 equals to 2, how can we this side what is the operator? I could not write x equals to b for this case. Same here. When you write L find d2 dx square plus u ddx plus 1. When you have something else here, you have to be very careful because this guy is also variable. So better to write then you will have u plus b, u plus b, u plus b, u plus b, u plus. So nonlinear operator, you have to basically, it is advisable not to write L as a single way. You have to write down complete field variable. Same thing here, I did that. I could not segregate the operator. I have to write complete field variable. Same here. Does it make sense? It is not there in the books for your kind information. Your textbook and other books, this kind of concept is not available. It is not there. I think with so much of example, I think concept is quite clear. I hope any of the problems now you can crack. Of course, I will not give integral differential system, but lot of complicated differential system I can give. And in fact, first one of the problems I was discussing, some of you said du dt plus e to the power u is nonlinear. Before moving into the next part, we'll go back to that problem. Du dt plus e to the power u, Lu. For example, here I cannot write L. I have to write Lu. L doesn't make sense. What is there? I don't know. I know only Lu. How can you prove it is nonlinear operator? Lu plus b equals to, who will help me? Tell me quick. Who can help me doing this? Yes, madam. D of d dt of u plus b plus e to the power u to the power b. Okay. So we have du dt plus dv dt plus e to the power u to the power b. That if you write down here to the power u, if you write down to the power b, then you have extra term minus e to the power u minus e to the power b. This is extra, and that's what this operator is nonlinear. I think everything I have done now. I think nothing is left out. So I think any problem will come to you, you will be able to attack and solve it. Right? Right? Okay. So operator part is actually done. So next we will move on some of the problems. So as I promised, any questions? Okay. Before getting into the systems, let me once summarize. Before I would like to go to the system, I would like to summarize the part what we have learned. Lu equals to differential matrix operator, and both has commonality, homogeneous and non-homogeneous. Differential, homogeneous, non-homogeneous I have seen. Okay. If this differential equation is there, say du dx plus u equals to 0, we can peacefully say it is a homogeneous system. For the algebraic system or matrix operator, what is homogeneous system? Ax equals to 0. Okay. I will get back here. Does it have always unique solution? I am throwing this question, going to the next topic. I will come back again, but I am just waiting for the answer. So the Ax equal to 0 is always Ax equal to 0. See, when you have this kind of thing, if I give the boundary condition, you can get the solution, which is unique. If I give boundary, how many boundary conditions you need? 2 boundary conditions. Highest derivative, 2. X equal to 0, x equals to 1 I give, you get me solution in 1 minute. You know how to do it. Ax equals to 0. Can you get unique solution? That's the beauty. Homogeneous differential equation is not that much naughty compared to homogeneous algebraic system. You always feel that, okay, algebraic system is easy, why to worry about He had to find over here. Can you get what is unique solution? Can you get what is unique solution? That's my question. Or what kind of solution you get? What are the possibilities?
Infinite inconsistent. The system is like inconsistent. We can have.
What do you mean by inconsistent?
Inconsistent as in if different solutions may come, but many solutions.
You are saying infinite solution, okay. Is there unique solution for Ax equal to 0? If unique solution, what is that? 0, yes. So you can see, if you get unique solution, you will get here 0 or trivial solution. If you have non-unique solution, they are infinite. But here, you can always get unique non-zero solution. We will come back here later. Okay? So let's go to the more on chemical engineering applications on the algebraic system. So first, then I was talking about the differential operator. I have talked about the operator. I gave the examples, and now we will be talking for the process calculations. You didn't like the subject, right? Which book you followed? Email Blau, okay. Bart and Bora. Any other? Let me see. Haugen Watson, okay. Next. Only 3 books I have heard. Email Blau, Bart and Bora, and Haugen Watson. Any other book? In fact, what is that? Any other book? No other. Local authors. I don't remember local authors. Okay. So thing is that when I entered chemical engineering, first course was Introduction to Chemical Engineering. After that, after studying that course, I thought I'm in a wrong branch. And when I studied process calculation, I thought I should leave chemical engineering because the book was followed in our time. Haugen Watson and Himmel Blau was the reference, not the main text. And if one reads that subject, they will not have any clue what is that the subject, and different problems and different approach. Like recycling, bypass, I think you remember all those things. Different problems, different approach. If the process flow sheet is big, you will be completely confused. You will see what is subject, why I am studying this subject. But I found now, at this, after so many years, that subject is the most interesting subject because you can apply the concepts what actually I am doing here, and the entire subject can be talked about on vector space. Okay, so I'll share one of the subjects, one of the problems with you on the process flow sheet. We have a reactor F1, and we have some other unit called D1. Flow stream is coming out F3, and from D1, one stream is going to D3, which is F4 stream, and bottom product is F7. From here, one product is going to some mixture. Product is coming out as F9. It is F6. From here, one thing is going to the top unit D2, which is F5, and one is coming back like recycle F2, and one is coming here, which is F8. This kind of typical system we have seen in process calculation, right? Only recycling is there, bypass, purging are not there. Okay? If all those things are there, it will be very complicated, and your teacher will be very happy because you won't be able to answer the question. Okay? So, and you will be all the time trying. I remember all those nightmares, those days when I see recycle, bypass, and purging. I didn't know how to solve this problem. My teacher will say that, okay, take that part and solve it. And he will give different problem. I don't know which part to take and solve the problem. And that subject will be a nightmare, and you have to mug up set of questions to answer. If those questions are coming, you can score, otherwise you're completely gone, right? Am I correct? Yes, okay, I got your point. You also got my point. So, how I suffered in this subject. And that's what, when I started my teaching career in IIT Madras, I started with this subject. Because I wanted to learn I wanted to know why difficult and why So much of problems, and then I want to share with you what's the interesting thing for this. So here R is reactor, N is mixture, then D1, D3 are the separator units, and F are the products. How many products? F1, F2, F3, F4, 5, 6, 7, 8, 9. Fantastic. 9 products. This is a typical chemical industry, chemical process industry. And I'm telling you that if you go to the process industry, you will see this kind of thing, and you have to deal with the plant engineer. If you talk plant engineer vector space, no, he will slap you. And all plant fellows will be coming to you, and they will say, okay, plant will be shut down. This plant engineer talking on nonsense. We cannot run the plant, and clients will not come to your place. They will say, what crap vector space you are talking? I want the product. Just my 10 tons per day is my demand. And if you talk about vector space, one day I'm losing so much of money. They won't care for vector space. But I tell you that with this concept, we can have any kind of demand of the plant engineer or the client or the plant operator who will be talking all kind of tons per day. This is the requirement, and in the using of the vector space, using your mathematical methods in chemical engineering, we can really talk or deal the plant engineers and plant operators. So I would like to share that part with you. Okay, so I have different units. How many units do I have? 1, 2, 3, 4, 5 units. Okay. First unit, mass balance. First unit, mass balance. Mass balance. F1 equals to F1 equals to, am I correct? Next is D1. D1, what is that? F3 equals to F5 plus F4, am I correct? D2. D2 is F5 equals to F8 plus, next is D3, what is that? Next is M. Just one person, I am getting confused. So much answers. Next, second one. Yes. F8 plus okay. Mobiles. Whose mobile is ringing? Whose mobile is ringing? Please. Otherwise, I will just stop the class. Please tell me whose mobile was ringing. I will not take any action, but I want to note down. Please. You don't have any courage? Shall I leave the class? Whose mobile was ringing? You don't have the courage. I'm really appreciating. You don't have the courage? Okay. So beginning itself I have lost faith on you. Shall I stop the class? Or shall I stop taking the class? Somebody else will be assigning? So then you have to find out your friend. Otherwise I cannot continue. Who is that person? I want that name. And I can promise you that I cannot take any action. Because I promise in the class. In that case, you should have the faith on yourself whose phone was ringing. Whose phone was ringing? You all have heard, right? Okay, I want that. Otherwise, I just make sure that I will not continue the class. Why so long? Why you are not honest? See, entire class is suffering for you. It's not expected from you. I am not going to take any action against you, but I am really surprised that after so much of my effort, I am doing so much, and you are actually having the cell phone on, which is not permitted. I don't want to know your name also. I am honest. You are not. I don't know your name. I am not taking any action. But I am surprised you took so much of time. Okay. So we have 5 algebraic equations, right? We have 5 algebraic equations. How many unknowns you have? How many unknowns you have? 9 unknowns. Question comes here. Can you get unique solution? That's the thing. Now you can see the mathematics here. This is a balance along R, along D1, along D2, along M, along D3. You have got 5 algebraic. We can say 5 independent. We will talk about later on independent algebraic equations alone. Algebraic equations. And we have 9 unknowns where I equals to 1 to 9. I will discuss a little bit what I mean here. If I say x1 plus x2 equals to 2, how many solutions you have? Infinite solutions. Excellent. Very good. Infinite. Why? Number of unknowns 2, number of equations less. So that is called as degree of freedom. That is called degree of freedom. We call as number of variables minus number of equations, independent equations. You can write either way, number of independent equations minus number of variables, no problem. If it is 0 for algebraic system, we can get unique solution. If it is not, we will get infinite solution. Okay? Now you can see your number of algebraic equation is 1, number of variables 2, your degree of freedom is 1. Degree of freedom is also saying that if I give another one condition, then only I can get independent unique solution. That number of degree of freedom 1 means you need to supply one condition. That means one algebraic equation. So when you are going to the plant, when you see that stuff, you see your equations, then you have to ask your plant engineer to give how many conditions? Yes, you are very correct. Correct. You ask your plant engineer or plant operator, boss, I cannot run the industry, I cannot have any problem to be solved if you don't give me another 4 flow rates. I need to have at least 4 flow rates so that I can get the solution. Any problem is there, any mass balance, I can immediately solve. So in that case, plant operator, you know what he will say? Okay sir, my demand is 10 tons per day of product. F9 is fixed. Okay, this D2 is what? Separator unit. This separator unit is designed such a way it cannot handle more than 5 tons per day. Okay. This separator is designed such a way it cannot handle 3 tons per day. This feed is fixed. That is the way. This is how I am solving. It's so easy, so straightforward. Once they are given, you can solve the entire process flow diagram. Alright? Clear? Let's look at how we solve it. So, what I am actually giving? What are my known vectors? F1, F9, then F5, F4. What are my unknowns then? These are known. Known or supplied by the plant operator. Known or supplied by the plant operator. And then you have to give the deliverable. Or what you can do that instead of having F9, you can actually give something like F6, because if you fix F1 and F9, there is no chunk. Okay? As a practical sense, you can say that, okay, I am giving this much of feed, how much F9 I will be getting. In that case, you can maximize F9. That is the chemical engineering, or is a businessman, I will see that. Why I will fix F9? I want to see maximum from the system. so that I can play all these variables and I can see when I can get F9. Okay. So I have F1, F6, F5, F4. How to construct Ax equals to B to solve? If you construct Ax equals to B, you can solve it. Right? How to construct Ax equals to B? So let's look at that part. My unknowns are F2, F3, F4 is not there, F7. First equation. How many are there unknowns? Another one is there, right? F8. Slight mistake. Okay, fine. Construct A matrix. Yes, I want to create more space here. First algebraic equation. What is there? F2 is there, right? What is my coefficient here? F1 is, F2 coefficient is minus 1. F3, 1. Then? Am I correct? Okay, right hand side also we finished that. It's better. Right hand side, anything is there? 1. F1. Right? F1 is known. Constant. Next equation. 0, yes. Please proceed. You are doing correctly. 0, then 1, then right hand side. F5 plus F4. Next equation. What is that? 1, 0, 0, 1. Next, right hand side. Fourth equation. 0, 0, 1, 0. Now, right hand side.
F4 minus F6.
Last equation. Everything is correct, please cross check. Everything is correct. So far, last equation. 0, 0, 0. Minus 1 or plus 1? 1. Minus 1. F8 minus, yes, minus F6, correct. All of you are agreeing with this construction of this? So now we can solve it. This part will be known. Supplied by the plant operator. This is known. Put in MATLAB, get the answer. Now any of the variables change. So we can now see this is in your hand. Degree of freedom, vector space, this kind of things. We talk to the plant operator, you will get very angry. But with that, any kind of systems like that, you can actually do this analysis and give the solutions to the plant operator. Next I'll be example actually. I have the liquid extraction that you can actually pick up one of the liquid extraction problem from your textbook. You can see that how the system actually works in liquid extraction system. Okay, that I'm asking you to go to the textbook or go to Trevor's book to see how the liquid extraction actually occurs. Next I'll be talking about some of the ordinary differential equation. I'm doing now the different kind of problems, chemical engineering problems, and how the equations actually work, and how in specific cases how you can solve it. This is a shell and tube heat exchanger. ambient temperature, hot fluid is going, cold fluid, same direction, no problem. It is Z equal to 0, Z equals to 12. So internal tube, we have hot fluid, there is a tube and there is shell, right? If you want to see the diagram properly, internal is tube, outer is shell. Shell is having the cold fluid and tube is actually having the hot fluid. What are the Gauguin equation? What is the Gauguin equation? Remember that you have got the space gradient and you have got the time dependency. You have got the space gradient, you have got the time dependency. Or if you want a steady state, no problem. First we talk about steady state. No time dependency, only the space gradient. How will you attack this problem? What will be the equation for the tube side? How about the balance equation? Fluid flow is going on. Fluid flow is going on and conductivity transport is negligible. Everything is flowing. Okay? Everything is flowing here. For the flow system, what is the balance equation? Energy balance equation. Accumulation term. How do you change? Rho Cp, dou T by dou T plus V bar. I'm just giving, if you don't know, that's fine. You can actually put Vx dou T by dou x. This type of convective term will be coming. Okay? And since if the flow is very high, there is no conductivity transfer because this will be actually dominating. So right hand side, the conductive transfer will not be there. And then rate of heat generation and destruction, and it will be coming, it will be lost from the wall. So volumetrically it will be lost. So what will be my equation? My equation for the hot side or hot tube, it will be rho of hot fluid, Cp of hot fluid, QH, some balance equation I'm just putting, dTH dz equals to minus QP dH minus Tc. Okay? So this is coming from here. Okay? Steady state, that means this term is going to 0. And this is the heat loss volumetrically from all the work. So this is the balance equation for the hot side. So you can see that we are having differential part here and the other part actually coming from for the cold side, shell side. What will the equation for the shell side? Rho C, CPC, QC, DTC, DZ equals to, it is minus or plus, it should be plus because heat is coming to the system, right? UP, TH minus TC. But ambient is cold, ambient is there. So heat will be lost here. Okay, what is that? This is U1, P1, TC minus T, not TA minus TC. U is the overall heat transfer coefficient. I think you remember that. Then heat exchanger, U is called as overall heat transfer coefficient. P is the perimeter, peripheral area or perimeter area. Okay? This kind of things, equation you can actually, if you see what is QH and all those things, if you want to the balance, you can see all the units and see left hand side, right hand side, both are same. This is the set of differential equation. Okay? This looks very simple, but if you want to solve it, it is not that straightforward. What are the variable here unknowns? TH and TC. Assume TA is the 25 degrees ambient temperature. So TA is known. How to solve this system? So first actually we saw process calculation. Now we are seeing heat transfer. For this simple problem, heat exchanger, shell and tube, how to solve the problem? This kind of problem you have seen earlier, right? This is not something new I am actually talking about. This has already seen in heat transfer subject. Kant's book or so many books, this kind of problems are there. Shell and Cubic exchange. My question is, TH and TC, all these properties are known. Hot fluid density, hot fluid CP, Q and everything is known. Those kind of things actually I will supply. So it's not an issue at all. Okay? So how to solve it? How to solve this kind of problem? Remember that this is not an independent differential equation. It has got TC. TC is also here. These are called coupled system. So you can see that simple shell and tube heat exchanger can give rise coupled set of ordinary differential equation. So one conclusion you got. I will take another 7 minutes. You got coupled set of ordinary differential equation. I will introduce one variable called th dot, which is dth by dz. Tc dot I will introduce as dtc by dz. Can I write this as algebraic system kind of thing, like vector format? th dot, tc dot, right hand side I put th, tc plus some other term. Can you fill in the blanks? Do you get my point? I want to write these two equations like matrix system. Now onwards what we do, if in a system we have more number of equations, always try to write in a matrix format. We can easily visualize. Something new we are learning today. Okay? What are my terms here? What are my terms here? Minus UP divided by rho h, cth, qh. Next. Plus UP rho h, qh. Next. UP rho c, cpc, qc minus UP minus u1 p1 is also there. Minus u1 p1 divided by rho c, cpc, qc. Am I correct? Right hand side, plus 0, then p1 pa divided by rho c, cpc, qc. Right? So this is the entire format. So, can I write this equation in this format? Yes or no? Yes. If this part is 0, you know how to solve. But now something interesting you got, that Ax plus b could be a differential, balanced by differential system. So now we are seeing something very interesting. dy bar dt equals to y plus. So it is called as vector differential equation. Something new you are learning today. See, simple shell and tube heat exchanger we have seen in your BTech class. Now we are seeing that this is giving rise vector differential equation, which is dy bar dt equals to y plus b. If it dy by dx, sorry, and if this is not there, we can get simple algebraic system. But now we are getting algebraic differential system or vector differential system. So heat transfer can give lot of interesting stuff on the and we'll also solve this kind of problem. We'll solve this type of problem. Next we'll be talking about one last example I'll take. You please write down the problem. Consider a spherical pallet. I'll talk about partial differential equation before leaving. Consider a spherical pallet of radius r. Consider a spherical pallet of radius r at uniform temperature Ti. consider a spherical pellet of radius capital R at uniform temperature Ti, dipped in a well-stirred bath. Dipped in a well-stirred bath maintained at a constant temperature capital T. Consider a spherical pellet of radius R at uniform temperature Ti, dipped in a well-stirred bath maintained at a constant temperature Ta, capital T underscore A. So, formulate the differential equation. That's the question. So, let's look at spherical pellet problem. Dipped in a bath. What actually happens? So this guy will be losing temperature and a time dependent problem, right? So the balance equation should be having time dependency, which is rho Cp rho T by rho T. And what actually happens? There is space gradient. Here the temperature is high, here the temperature is low, because directly contacting cold water. So, and what will be the thing? Will be gradient, and that gradient will be determined by the rate in minus rate out, and shear energy balance says that K, what is that? Into 1 by R square, rho R square, rho E by rho. This you will get from bar square right foot, if you don't remember. Okay? You don't have to remember in this class. Whatever is required, I will give in the exam or I will give the expression. So this is the typical example of the partial differential equation. So simple problem. One hot ball, okay? You got it. You want to cool it. You put in a bath. It is actually any day-to-day problem also. You got some hot stuff. You want to cool it before cooking or something. Or cooking something. You want to reuse it. You put in the cold water. That's what we do too. So that you have, or some hot cooker you got. You have to open the cooker. You put sometimes cold water to take it out. Every day we are cooking. Every day we are actually seeing the kitchen. Kitchen is giving partial differential equation. Kitchen is giving partial differential equation. It is the function of time and how to solve it. So heat transfer is this kind of transient problem, for the cooling kind of problem, giving the time dependency and the spatial dependency, and which is nothing but partial differential equation. It's nothing but partial differential equation. How to solve this type of problem? Any idea? I have not discussed how to solve it. But this kind of problems we have seen earlier. And of course, solution technique I can tell you, or if you can tell me, I'll be happy. Anybody knows how to solve it? We need to have a boundary condition. We need to have two boundary conditions here. We need to have one boundary condition in time direction. How to solve it? Pardon? Separation of variables method. By separation of variables method, you can actually solve it. So I'll come back for this kind of equations, and I will talk. So basically, this type of examples, you can see your first chapter, and you can get the stuff. And I have given the assignment to you. With that, you can actually